primary goal of the Water Sentinels is to get citizens involved and engaged in river protection, get them involved in watershed protection, and that's really what we're about. Water Sentinels have been involved in water quality monitoring work primarily, but we also do, coordinate cleanups, do education and outreach to kids and youth groups to try to get them involved in clean water and being and caring. The primary focus of the Arizona Water Sentinels program has been the Verde River since its inception. So we've been going out to the river for 3 years and monitoring water quality for a variety of parameters, and we're going to continue that this year in 2010.
And can we save the river is a very good question. Do we have the capacity to save the river? Yes, we do. Do we have the political will to save it? I think that's still somewhat unclear. In Arizona and in many places in the Southwest, we've demonstrated pretty clearly that we can kill a river by basically draining it of its very essence. You need look no further than the Lower Salt River, the Santa Cruz, and the Gila to see some of the rivers that have suffered that fate. Now we are challenged with trying to save some of these rivers, and of course for this year called the San Pedro and the Verde are a couple of very key rivers.
Over there. She works out of the Yavapai County Cooperative Extension Office. She does water education. She works with Master Watershed Stewards as well. And Dr. Shauna Rock up here, she does some work with Arizona HEMO. So we are very fortunate to have some great folks supporting us on this project. Moving in more now to what we hope to achieve through our water quality monitoring. We are going to be looking at various field and laboratory parameters that closely pertain to those impairments that I mentioned. And so, all of these parameters are things that do exist in nature at certain concentrations, but when due to human impacts or mismanagement or certain land management activities, there may be they may exceed those concentrations.
It takes a lot of energy to keep that material up in the water column. It settles out relatively quick, but the more material you add, the more energy is actually taken up from the water. And so the energy goes lower and lower as it has to carry more and more sediment. And you get to the point at which all that sediment just drops out. That's what's happening right here.
Another important thing to identify, there's waterborne transmission of some of these organic pollutants. So it just doesn't go from the pipe to the water to the person. You have to think about the different routes for these organisms in the environment when you're going out, when you're collecting samples, when you're identifying those places that you're going to collect samples in your watershed. So for example, let's just follow this down. So we've got excreted from animals and humans, and then we come over here to land runoff, rivers and lakes, and then someone goes swimming, recreation, and then it gets to humans. But that's not always the route. So again, something else to think about.
Measure in here. And we also measure the velocity. We use Marsh McBurney Flowmate 2000 flow meter. There's a bunch of different kinds out there, but I'll get a little bit more into that. I really do like this picture because it shows what each person who gets to come out with us does at each individual site. We have somebody measure the depth, we have somebody measure the flow, we have the most important person out there, and that's the one taking the notes back here.
Got the dissolved oxygen concentration in the water. This is the instrument that does it. It's called a DO pen meter, and it's basically the first thing we want to do when we use this instrument is calibrate it here streamside.
I would pick 36. We don't call it.
And now it's milligrams per liter. So now we're going to go and stick it in the water, and like Steve said, you can move it around a little bit. That's kind of why we, have the lanyards. Kind of move it around to keep the oxygen moving across the membrane. And basically, you're gonna watch the screen until it stabilizes.
Farther out the stream, just so they're equal and that you are characterizing the major part of the flow, which is just the big energy right here. Does anybody know what this part of the stream is called? Bowwag! Yes, it's a really great word. This is bowwag. It's the deepest, fastest part of the stream. That's where the most energy is.
This is the part where the kangaroo